Good morning. Here I'll solve an illustrative example for cascade analysis. So let me state the problem. The data for a compressor cascade is given below. The blade entry angle alpha 1 dash is given as 50 degree. Blade exit angle alpha 2 dash equal to 30 degree. Incidence I is equal to 3 degree. Deviation dull 2.5 degree. Pitch to cut ratio S by C is equal to 1.1. Stagnation pressure loss del P0 is stated as 10 millimeter of water gauge, that's water column. You'll have to convert to the meter of air. Velocity of air at entry is 70 meter per second. Air density is stated as 1.25 kg per meter cube. Calculate lift coefficient, drag, and the blade efficiency, eta B. I'll solve the problem now. So let me state the data. Alpha 1 dash is given as 50 degree, alpha 2 dash 30 degree, incidence 3, deviation 2.5, pitch to cut ratio 1.1, total pressure loss del P0 10 millimeter of water column, C1 centimeter per second, rho is the density 1.25 kg per meter cube. Now it's a compressor cascade, so as the flow passes through the blades, it will decelerate. So C2 exit velocity must be less than C1. Now here S is the pitch, and C being the chord, right? Z is the axial direction which I am indicating now. And look, C1 is the inlet velocity. This is the C1 that makes an angle alpha 1 with the Z axis. And similarly, C2 be the exit velocity that makes an angle alpha 2 with the Z axis. I have shown here alpha M. Thus, lift will be perpendicular to the vectorial mean velocity, and drag will be along the Cm, where Cm being vectorial mean velocity. Now, I have superimposed here the velocity triangle, both inlet and exit velocity triangle. And look, this is the axial component of C is Cz. Cz at inlet and exit must be equal to same, as the mass flow rate remains constant. So here I have indicated C1. This is the C1, C2, C1 making an angle alpha 1 with the Z axis, and here similarly alpha 2, and thus I have defined alpha M. Look, this is the alpha M, and this is the vectorial mean velocity Cm. C theta is the tangential component, so this distance would be equal to C theta 1, and this distance is nothing but C theta 2, and this is that I have indicated now is del C theta. Del C theta would be equal to C theta 1 minus C theta 2. So after drawing velocity triangle and a schematic for cascade, I can easily solve the problem. Now flow angle alpha 1 can be written as alpha 1 dash plus I. Now both the values of alpha 1 dash and I are given. So if you sum these two, it will be 53 degree. Similarly, blade flow angle at exit alpha 2 will be alpha 2 dash plus del deviation. So exit flow angle is equal to blade angle plus deviation. So that will be equal to 32.5 degree. Now I have evaluated alpha 1 and alpha 2. Hence I can calculate alpha m from the relation tan alpha m is equal to half into tan alpha 1 plus tan alpha 2. So let me write now the relation tan alpha m is equal to half of tan alpha 1 and tan alpha 2. Now one can evaluate alpha m. I have calculated alpha m. I got alpha m is equal to 44.48 degree. After evaluating alpha m, I'll now calculate the value of drag. Now, the expression of d is equal to del P0 S into cos alpha m. That is, del P0 is the pressure loss, S is the pitch into cos alpha m. Now, from the velocity triangle, I can write another equation that C1 cos alpha 1, C1 cos alpha 1 is equal to Cz. That's also equal to Cm into cos alpha m. So this is nothing but Cz. Thus, from this expression, I can calculate Cm equal to C1 cos alpha 1 divided by cos alpha m. So this might now you give some equation number 1. This may be equation number 2. Now from the definition of drag coefficient is defined with respect to vectorial mean velocity. Thus CD equal to D divided by half rho Cm square into C, where C being the chord. Now, from equation 1, you can put the value of drag over here. And from equation 2, you can put the value of Cm. So if you do that, the expression of CD would be S by C into del P0 divided by half rho C1 square into cos cube alpha m divided by cos square alpha 1. Now I have expressed CD in terms of del P0 and C1, and thus the quantities like cos alpha m and cos alpha 1 would come. Now if you see the expression of CD, all quantities are known to you. Thus you can evaluate it CD. I have evaluated CD. The value of CD would be 0.0355. Before that, I like to state one point, that del P0 was given as in terms of del P0 was given in terms of 10 millimeter of water column. You will have to convert to meters of air. So if you convert it in terms of meter of air, so it will be 98.1 this meter of air, right? Now evaluate now the value of del P0 and other quantity. So you can get CD as 0.0355. Thus I have evaluated the value of CD. Let's go ahead. After evaluating CD, I'll go for CL. I know the expression for CL as twice S by C into tan alpha 1 minus tan alpha 2 within the bracket into cos alpha m minus CD into tan alpha m. Now you know all the values, so you can evaluate CL. The CL would be 1.048. This is the value of CL. Look, for the problem CD by CL is much less than 1. Thus we can use the relation for blade efficiency eta B is equal to 1 minus twice CD divided by CL into sine twice alpha m. Here you know CD and CL and also alpha m, so you can evaluate blade efficiency. Eta B would be equal to 0.9322. Thus, the blade efficiency becoming 93.2%. Thus, I have calculated CD. CD is equal to 0.0355. Evaluated CL as 1.048, and thus blade efficiency is 93.2%. Thank you for listening.